All right, everybody. So now let's get to what we've been talking about for a good little while, matter. Okay, this is matter. And specifically, we're going to be talking about the states of matter. But Dr. J, what exactly is matter, right? Okay, so let's just go back. We talked about in the very beginning, chemistry. Chemistry, like I mentioned before, a simple definition is that it's the study of matter. And we understand that matter has a composition, right? The way things are composed, but also it has a structure to it, right? Whatever the makeup is of it, and then the way that they come together. This is what we know is composing of matter. But what exactly is matter, right? Because we just said chemistry is the study of matter, which I said earlier is the study of everything. Well, how can matter be everything, Dr. J? Well, let's look at the definition. Matter is anything that occupies space and has mass. Let me read that one more time. Matter is anything that occupies space and has mass. So basically, you mean to tell me that matter is, if it takes up some type of space, right? And if it has some type of mass, right, to it, then it's matter. That's correct. That is correct. So this phone, I keep pulling up this phone. This phone is matter because it's occupying space and it has mass. This pen, what? It's occupying space and it has mass. So this is matter. Like I could do this all day. This shoe is occupying space. It has mass. It's matter. These glasses occupy space. It has mass. My body, me, I occupy space and I have mass. You, yes, you. Looking at this right now, you occupy space and you have mass. Okay, so matter is everything. That's the reason why I say chemistry is a study of everything. Because literally with chemistry, you could study anything and everything if you really wanted to. Okay, I'm just saying, you know, you can't do that with other sciences, but you can do that with chemistry. Okay, so that is matter. Okay, you're studying chemistry, you're studying everything, and that's because you take up space and has mass. Now let's talk about what I call states of matter. Okay, now states. What do we mean by states, Dr. J? I'm not talking about, you know, New York. I'm not talking about California. I'm not talking about that type of states. I'm talking about physical forms. Okay, so the physical forms are what we're going to call states. Okay, so that is the same thing. States, physical forms. So when I say states, I'm talking about solid, liquid, and gas. Okay, we have three states of matter. Now there's one more. Okay, plasma. You know, but we're not getting into that. Okay, we're not going to get into that. I will say there is one more state of matter. If you want to learn more about that, put in the comments. You know, I could definitely have a video just about that subject. But we're going to stick with the basics because, you know, this is the ones that we see every day. Solids, liquids, and gases. Okay. Now, let's talk about solids. So solid is a state of matter. Okay. So let's look at this example here. Specifically with solid, solid is basically anything that it's going to keep the shape in the volume. Okay, it keeps the shape in the volume. So a solid, right? Like what I said earlier with this pen, it's going to keep the shape. So it's always going to say the shape, and it's going to keep the same amount of volume. So it's not going to change really. Okay, and because of this, right? This is what we consider to be a solid. Now solids, going on that micro scale, right, of how solids are structured and composed, right? Solids are very compact together, okay? And we talk more about this in Chem 2, so if you in my Chem 2 class, you know, go to that. But right now, we're just going to talk about solid matter, right? This is how solid matter is. It's really compact to each other, okay? Liquid matter. Let's talk about liquids. So liquids, right, you got some water or something like that. I wish oh yeah, I do. I got some water right here. You know what I'm saying? Got that water. I got some water. So liquids are basically, right, they're going to be different from solids. Now, how exactly are they different from solids? Well, specifically, liquids keep the volume, but they don't keep the shape. Okay, that's the key thing about liquids. So liquids will take the shape of whatever container they are in. So if they're in this Erlenmeyer flask, okay, they're going to take the shape of this Erlenmeyer flask. But if I put in 20 milliliters of that liquid, right, it's always going to be 20 milliliters of that liquid. That's not going to change. But if I took this same liquid and put this in, for instance, like a bowl, right? And put that in like a regular, cereal bowl. Put it in a bowl. Now that liquid is going to take the shape of that bowl. But it still has the same volume, 20 milliliters. Okay, and that's the key thing with liquids. Okay, and with liquid matter, right, if we go on that micro scale again, we can see, right, this is the reason why. Okay, because of the way it's structured. How is it able to change its shape like that, right, but it still keeps the same volume? Well, it's because, right, liquid matter, they're not compact, put together like a solid is, right? Solids keep the shape and volume together, and we can see that on a micro level. Liquid, though, they're not compact, they're close together, so that's the reason why they have the same volume, but they're not like a solid, so they're able to change around, right? They're able to change what they're doing, okay? Now, this is different from the last matter, gases. So gases, if we look at this container here, right, what do we notice about this gas? Well, gases take the shape and the volume of whatever container they are in. So we see here, right, this gas molecules, right, this gas matter has taken the shape of this entire Erlenmeyer flask, as well as the volume of the entire Erlenmeyer flask. How are gases able to do that? Go on that micro level. It's all about those particles that we cannot see, right? Explaining everything that we do see. Woo! You see that? It's crazy. All right, but anywho, basically, right? They're free. Look at everything else. All right, solids, compact, can't move around, so they're going to stay the same. Liquids, still close together, right? But they can move around a little, but they're still going to be the same, right? Not going to change. Gases, they're free. Okay, they're independent of everything else, right? So this gas atom can do whatever it wants to. And because of that, that's going to impact the macro scale. Okay, so this is how it's able, right, to spread all the way across this Erlenmeyer flask, taking the shape of not only the container, but also the volume of the entire thing, man. And that's because of the way they're structured. Okay, so structure is very key, man. We definitely talk more about this a little bit later on.